Hello, water managers. My name is Simon Evans, part of the Water Management Systems Division at the Hydrologic Engineering Center. I'm going to be covering HEC-FIA for SWMS today, part of the SWMS Prospect course. This is the fourth part of 4 videos on this topic, and in this video we will be covering the flood damages reduced computations in HEC-FIA and SWMS. USACE is required by Congress to submit an annual report stating the damages reduced by each of the core projects for that year. This report is important to show the ongoing value of our reservoirs and levees to the country. We are working to modernize how we report damages reduced using SWMS forecasts and HEC-FIA. So historically, districts each had their own approaches to calculating flood damages reduced, with the majority of districts using some form of the legacy approach outlined here. The legacy methodology that honestly some districts still employ and are working to transition to SWMS, that involves picking points off a hydrograph and plugging it into a stage damage curve. Now, there's a lot of data baked into these single curves at the specific location, long reaches with mixed consequences types, and the hydraulics of river systems are built into these curves. Some of these curves are from the original construction of the project, sometimes 60 plus years old. As you can imagine, there's a few issues with this approach. All of these inputs are quickly outdated. It doesn't account for changes to the watershed since the curves were made, particularly land use. Structure, inventory, and hydraulics can change dramatically since these curves were created decades ago. Some examples could include agricultural land being converted to residential neighborhoods, or industrial areas shutting down and no longer having those structures along the river. Much of the time, these legacy methodologies are undocumented approaches, and it's very difficult to provide justification for these approaches. All this sums up to making it a bit of a black box analysis. So the approach that districts are expected to implement is to use FIA and SWMS. So this combines the best available inventories, hydrologic and hydraulic data, and terrain data with the most up-to-date modeling tools. This allows us to compute observed inundations, like the one here, and then also simulate unregulated without levee inundations. So the red inundation is the regulated. So that's the with project, so with the reservoir, like what actually would occur in an event. And then the larger inundation shown in blue would be a simulated what would have happened if the project, the reservoir, and the levees were not there. And then we can compare using FIA to compute the damages that our project's reduced. And we tell the story about what the event would have looked like without the project in place. And this approach provides a defensible answer to how our projects provided benefit to the country. Now, there are 2 main approaches to calculating flood damages reduced within FIA and SWMS. The first approach is to use an estimate that uses only the output from 2 HEC-RAS simulations, the regulated and unregulated simulations. So you see here with levees for both cases. So how do we calculate the without levee scenario? So FIA can estimate the without levee damages to compute the other 2 without levee scenarios. This would be the regulated and unregulated scenarios, i.e. with and without dams. So FIA does this by assigning structures an in-channel water surface elevation that it picks from the adjacent stream centerline. So looking at the HEC-RAS model, FIA would determine the levied area and then provide structures that are behind the levee with a water surface from the main channel. A levee reduction factor can also be applied to levees where the without levee water surface elevation may be an overestimate. So if you wanted to reduce that channel, you can provide a reduction factor. So this approach works pretty well in situations where the area behind the levee is uniform and would have a similar water surface to the main channel. So examples would be like pocket levees or areas where you don't expect a big change in the water surface throughout the area. However, this approach is not appropriate in situations where if the levee was not in place, inundation may not return to the channel or really have a different hydraulic approach. So maybe it would break out of the channel and then go and not return, have a different course. So in these situations, in these more complex cases, we need to have 4 separate RAS simulations as input to FIA. So we have the regulated and unregulated with levee situations or simulations. And now, new approach available in HEC-FIA 3.3, we can now provide one FIA simulation, 4 separate RAS outputs, so without levees. Now, this does require additional work in HEC-RAS to create a new RAS geometry that does not include the levees. So you need a without levee geometry. And this can be done either through editing if the RAS geometry, taking out lateral structures that may represent the levees, or directly modifying the terrain using RAS mapper and the terrain modifications to remove the levees. This approach directly accepts HDF RAS results, so there no longer need to save to disk the max depth TIFFs. And this also, as of FIA 3.4, allows for agriculture damages within this single FIA simulation. And then finally, this is an example of how an inundation boundary can drastically change with the removal of core reservoirs and levees. And SWMS and FIA can not only calculate annual damages reduced, but also by providing maps like the one shown here, it can help inform the country on the value provided by USACE products, or USACE projects. This concludes the 4th and final part of the HEC-FIA in SWMS lecture. If you have questions about our software, need some help, or are looking for additional training, check out these links. They also can be found in the description below. Thank you for your time.